Oh, maybe I should just start over because I probably just want the intro to go. Hey, welcome back. Man, what a doozy that last game was, right? So we're now in the middle of Prep Test 2. The third section of Prep Test 2 is the games section. A couple weeks back, we finished the first game of that section, which was a super easy order game, specifically what we call that tree branch diagram game or a range game. One of the easiest games I've ever seen. We figured out basically the entire setup with one exception before we jumped into the questions. So perhaps it should have been unsurprising that it was followed up by quite a game. Grouping game where we did not know the sizes of the groups. And could we reuse the elements? No, we couldn't reuse the elements, so that was nice. Man, can you imagine if we'd been able to reuse the different people in their apartments in that game? But in any case, definitely not the hardest game I've ever worked, but in terms of the difference in difficulty from the first game to the second, it was quite a ramp up. It was such a big gap, in fact, that I have a strong expectation either today's game or the next one, the fourth game of this section, should be quite a bit easier than that second one. And again, you always want to try to work the games roughly in order of easiest for you to most difficult for you. So that way, whatever you don't get to in the end is particularly hard stuff that you might have been more likely to miss anyway, or that just would definitely take you a lot of time. So I don't know what's going to be the case right now. Again, I have I'd say a moderate expectation that this is going to be a little bit easier than that last game that we did. But let's jump in. There's only way to know. Let's find out. Again, this is questions 13 through 17 from the third section, the games section of Prep Test 2. Hannah spends 14 days exclusive of travel time in a total of 6 cities. And that's the setup. Okay, I'm not feeling great about this. I'm thinking this is not seeming super easy right off the bat. Clearly, it's not an order game. Arranging like cities into a certain order or something, but we jump right into the clues. Sometimes you want to look at the questions to see if you can figure out what a good diagram will be. Okay, it looks like it's, if I'm looking at 15, if Hannah spends 3 days in the cities of country Y, 7 days in the cities of country Z, so it's kind of distributing the days themselves to the different cities and countries. Each city she visits, so I think we just need to jump into the clues to help us figure out the diagram here. Each city she visits is in one of 3 countries, X, Y, or Z. Each of the 3 countries has many cities. Okay, so they're not naming the cities, and as I look at the questions, I don't see a lot of names, but I do see 16 bringing up the city of Nomo. That's a little strange. Okay. Hannah visits at least one city in each of the 3 countries. She spends at least 2 days in each city she visits. She spends only whole days in any city. Wow, so they're kind of like 3 levels of what's going on here. There are the countries, there are the cities she visits in those countries, and then there are the days she spends in that city. So I don't know. My expectation right now is that this is not necessarily going to be any easier than the second game. So this could just be a hard game section, which remember is actually to your advantage. So it doesn't feel great in the moment, but let's see if we can figure it out. I think the best diagram is probably going to be country X, country Y, and country Z, and try and keep track of which cities can be visited. I don't know how many it is, and to make sure we don't end up running out of days. It's a little weird because we don't really have elements here. Each city she visits is in one of 3 countries, so that's really building the diagram. I'm looking at the clues again to symbolize anything that we need to. Each of the 3 countries has many cities, but we're just going to jot down what she visits, so I don't really think there's anything to write there. Hannah visits at least one city in each of the 3 countries. Okay, so that we can symbolize because we need at least one blank in each of the 3 countries. So every blank right now is going to represent a city. Maybe I should symbolize that over here, just so I remember every blank is a city. She spends at least 2 days in each city she visits. Okay, so each blank we're going to let stand for a city, and we just want to remember she spends at least 2 days. So this is 2 plus. So every time she's in a city, it's at least 2 days, 2 or more. She spends only whole days in any city. Okay, so on any given day, she's just in one city. You know, not a ton to go on here. Not really a set of elements that we're placing necessarily. And so anytime that happens, you want to jump into specific questions, which fortunately, I think all 5 of these are specific. So, maybe things are looking up here. Let's try number 13 first. If Hannah spends exactly 8 days in the cities of country X, which of the following cannot be true? Okay, so for number 13, to spend 8 days in country X means she has to be visiting no more than 4 cities, right? So we're going to say up to 4 blanks. Because again, she can spend more time, but this scenario would be 2, 2, 2, and 2. And that's 8 of her days. There were 14 days total. Maybe I just want to jot that down. 14 days total. And so I only have another 6 days I could distribute. You could do that in 2 cities for Y, 1 city for Z. You could also do 1 city for Y, 2 for Z. Of course, it's also possible to do 1 and 1 and just have these be 3 days each. So these scenarios are all 2, 2, and 2. You could even imagine a scenario where she only spends 2 days each in Y and Z, and the cities of country X end up with a few more days distributed around. I guess I'll just leave that jotted down. Let's see. She visits exactly 2 cities in country X. Well, they said cannot be true. That could definitely be true because she could just do 4 and 4 instead, right? So no, A is not must be false, cannot be true. She visits exactly 2 cities in country Y. That's definitely possible. Cross off B. She visits exactly 2 cities in country Z. Again, definitely possible. Cross off C. She visits more cities in country Y than country Z. Also possible. She visits more cities in country Z than in country Y. That's also possible. Oh my goodness. Okay. This is why we do the specific questions. I just completely missed in a total of 6 cities. I just wasn't looking at that at all. So we actually only have 6 of these cities. 1, 2, 3, 4, 5, 6. And we're distributing 14 days to those 6 cities. Obviously, even if we did 2 for each of them, that would be 12 days. And so really we're only ever distributing an extra 2 days. Okay, so let's get rid of this. Let's rethink this now. Very good. Yeah, so really I should say the other thing going on, again, it's possible this is just 2 really tough games in a row, and this is just a tough games section, but if there's just something that's not clicking at all, particularly I would say on a game like this where it seems like there's hardly any setup at all, you might be missing something. I was missing something here. I missed, there are 6 cities. So those essentially are our elements. And again, that does lead us to some deductions. The most any city can have would be 4. So basically it can be 2 or 3 or 4, but nothing else is possible. Again, if I distribute my at least 2 days to all 6 cities, that's 12 of the 14 days already. I only have 2 extra days to distribute. If I have a city with 4, then every other city is 2. Really, it might be worth just writing down the only possible distributions are that we have 5 cities with 2 and 1 city with 4, or that we have 4 cities with 2 and then 2 cities with 3, but there's really no other way to distribute the days in this case. All right, so this is clicking a lot better. So number 13 now, which of the following cannot be true? She spends exactly 8 days in the cities of country X. So the question is, how do we get a sum of 8? It could be 2, 2, 2, and 2. It could be 3, 3, and 2. It could be 4, 2, and 2. And I think that's it. That's the only way to get 8 days. Yeah, I'm not seeing anything else. Okay, so we know, of course, we have to have at least 1 city in each of country Y and Z. In this last scenario, it's easy enough because once we have that day of 4, everything else is 2. For that matter, in this second scenario, we also know, since we've used both 3s, it has to be 2 and 2. In the first scenario, it would have to be 3 and 3. And so really the only question is, where goes the other 2 in each of these scenarios at the end? All right, very good. What cannot be true? She visits exactly 2 cities in country X. There it is. That's impossible, right? No distribution ends up having that. If you wanted to check, you could see all of B, C, D, and E and these other scenarios that we jotted down. But again, you want to try and get out of that habit. We want to move on, especially if this setup has given us a little trouble, and now we want to pick up some time. If Hannah visits an equal number of cities in each of the countries, what is the greatest total number of days she can spend visiting cities in country X? She visits an equal number of cities in each of the countries. Well, there's 6 cities, so the only way for that to work would be 2 in each. And if we want to know what is the greatest number of days between 2 cities, well, it's either 2 and 4 or 3 and 3. But either way, it's going to be 6 days, and so D has to be the answer to number 14. All right, here we go. Now we're cooking with gas, as they say. 15. If Hannah spends 3 days in the cities of country Y and 7 days in the city of country Z, which one of the following must be false? Well, let's jot down at least one blank in each. And let's see, 3 days in country Y. Well, the only way to spend 3 days would be to visit one single city for 3 days, because there's no other sum of 3. So that's done. I might actually block that off just so I remind myself that's done. 7 days in country Z. There are a couple ways to do that. Being that we're using a 3, we have to be using this second scenario. So actually I said there's a couple ways. There's really only one way. You use the other city with 3 days, and then you use 2 cities with 2 days each. How many days have we used so far? 2 and 2 is 4, and 6 is 10. So that means the other 2 cities go in country X and are used twice each. And everything is done. Which of the following must be false? So I'm going to cross it off if it could be true. A, she visits more cities in country X than in country Y. Well, that is true, so that's definitely not a must be false. She visits exactly 2 cities in country X. Again, that is true. She visits more cities in country Z than in country X. Again, that is true. She visits exactly 2 cities in country Z. That is impossible, so it has to be D. Awesome. Okay, I love it when things start to work. Doesn't it feel so much better when things start to work? If the city of Nomo is in country X, and if Hannah spends as many days as possible in Nomo, and as few days as possible in each of the other cities that she visits, which one of the following must be true? Okay, well, so here's Nomo. Not that the name really matters. Most days possible, we've already said that that's going to be 4. We know she has to be in country Y and Z, at least 1 city each. Everything else is going to have to be 2. But as far as where they go, yeah, I have no idea, right? So at this point, if you kind of refer over here, we've got 3 cities with 2, and we can distribute them any way we want. So any country right now could get all 3 of them. Any country could get 0 of them. There are lots of possibilities. All right, let's take a look at the answers. A, Hannah cannot visit any other cities in country X. I don't think that's true, because we could put 1 in each, right? And that would be all 14 of our days, and she visited 2 cities in country X in that case. So no, that does not feel like a must be true. Hannah can visit 4 cities in country Y. Sure, because we could put all 3 of the other cities into country Y. Now this is a little confusing, because normally I would think, okay, so that can be true, but is it a must be true? But the word can is actually in the sentence itself. It must be true that she can visit 4 cities in country Y. So I'm pretty sure that's going to be the answer. Because this one's a little confusing, I might quickly check the other choices just to make sure they're in fact not must be trues. Hopefully they'll even be false. Hannah can spend 6 days in Nomo. Well, we know she can't ever spend any more than 4 days somewhere, so there's no way C is true. Hannah cannot spend more than 4 days in country Z. Well, clearly she can, because we could just, instead of having these 3 cities in country Y, we could put them in country Z. So one thing you want to notice in this game is all the countries are the same. So unless a specific question gives us certain information about a city, they're interchangeable. So anything that would be true of Y is also true of Z. So in the same way that Hannah could visit 4 cities in city Y, she could do the same thing in country Z, which would clearly take more than 4 days. So no, that's not a must be true. Hannah can visit at most a total of 4 cities in countries Y and Z. Well, again, no, because we can see 5 of them. And so I'm going to cross off E and confirm it is in fact B. But that is a little bit strange, right? Okay, 17, last question here. If Hannah visits a combined total of 4 cities in countries X and Y, what is the greatest total number of days she can spend visiting cities in country Y? If we want to know the greatest total number of days in city Y, then we want the least as possible. possible in cities of countries X and, visits a combined total of 4 cities in countries X and Y. We're trying to maximize country Y, so let's do just 1 2-day city in country X, and then the other 3 cities in country Y, which means Z would have to be 2. But again, we're trying to maximize Y, so let's minimize both X and Z, and that means these 3 cities, doesn't really matter how you arrange them. Let's say it's the 2 3 3. If it's the 2 2 4, it's the same thing. Either way, it's going to be 8 days, because we used 6 days in countries X and Z. So 8 days is C, and there it is. That's the game. Let's check our work. A, D, D, B, C, 13 to 17, A, D, D, B, C. We did it. Yay. Not bad. Little hiccup there at the beginning with kind of a weird setup. We were missing something from the setup that made that harder than it needed to be. Anytime you notice a game seems more difficult, it's hard to say more difficult than it needs to be. Sometimes there are just genuinely difficult games. But if it's difficult in such a way that you can't even diagram it or set it up, you're probably missing something. And that's what I was doing here. I was missing the 6 cities, which obviously was the key to the game. Once we had that, though, not so bad. Kind of a weird question on 16 with a can in the sentence of a must be true, but we got there anyway because we were able to eliminate the other choices. Process of elimination, always your best friend on a standardized multiple choice test. And that's that. We done did good. Yeah, I hope you find that helpful. Like and subscribe. As you know, if you are a subscriber already, you wouldn't know this otherwise. I am trying to work through all 300-ish games of the various prep tests that are out there and available. So if you have a game you want me to move up in the order, let me know, and I'm happy to do so. But otherwise, I'm just going to go start to finish, and we just finished the 3rd game of the October 1991 Prep Test 2, 3rd section, 3rd game, 3rd everything. I'll see y'all later.